What if I tell you that in just one drop of water, there are more molecules than there are drops of water in all the oceans of Earth combined? Can you believe that? But that is true. That is approximately 1.67 into 10 to the power 21 molecules in a single drop of water. But here is the incredible part. Chemists not only figured out how to count these invisible particles, but also created an entire mathematical framework to connect the microscopic world of atoms to macroscopic world that you can measure. Welcome back to Mole Concept Chapter Session 2. I'm going to guide you through the most fundamental concepts in chemistry, the mole. So grab your periodic table, calculator, and let's dive in to the world of Avogadro's number rule supreme. Before diving into moles, we have to understand why atomic masses aren't always whole numbers. Why they are not whole numbers. For example, if you are taking chlorine, the mass is 35.5. Why is it so? To understand that, we have to meet isotopes. I will give you the introduction to isotopes in a while. Before that, let's understand what are these different atomic masses are. Relative atomic mass and average atomic mass. Relative atomic mass, it's a ratio of the average mass of an atom to the 1/12th mass of carbon-12 atom. Right? And this is dimensionless quantity. So we are comparing the atomic mass with 1/12th of carbon atomic mass. Why we are taking carbon? Why not other elements? Or why not oxygen? Carbon is most abundant element in the entire periodic table, and carbon 12 we just mentioned as carbon 12. Why only 12? For that we are going to move forward. To understand average atomic mass, we have to know about isotopes. Average atomic mass is nothing but the average weight of the isotopes. So what is isotopes? Isotopes are those particles which have same number of protons but different number of neutrons. Here are the examples. Hydrogen isotope, where that is 1H1, the neutron count is 0. Hydrogen 2, that is deuterium, where the neutron count is 1, and tritium, the neutron count is 2. You very well know how to count the neutrons, right? It's just a mass number minus atomic number. Okay, you can take oxygen isotope, which is having 16, O16 and O18. Great. So these are the isotopes. Similarly, you have chlorine 37, chlorine 35, and for nitrogen 15, nitrogen 14. So many elements in the periodic table do exist in isotopic forms. Okay, so why we are taking isotope? Because that is there, but comparing that isotope, taking an average of that isotope, we are deciding the mass of an element. But one more factor is there, that is percentage abundance. It is defined as the percentage value of the isotope present in the nature. Okay. So for example, if I am taking carbon 12, I told you that is more abundant. 99% is present. It is not present. Don't think like 99% of the earth is made up of carbon. I am just saying you, comparing carbon 13 and carbon 12, 12 is present in 99% and carbon 13 is 1%. Okay, so how can you calculate the average atomic mass? We are going to use a simple formula, mass into abundance. Here we took it as a percentage, so divided by 100, that is 0.99 plus 13 into 0.01, which will give you 12.01. That is the mass of carbon. That is the average mass of carbon. Okay. Moving on to the calculation part. Let's do this problem. What is the average atomic mass of chlorine if it contains two type of atoms having masses 35U and 37U? U is a unified mass. The relative abundance of these isotopes in nature is 3:1 ratio. So chlorine 35 is 3 part and chlorine 37 which is 1 part. Or you can take it at 75% and 25% also. Okay, let's calculate the average atomic mass. So for that we have to multiply 35 into, I'm taking it in ratio, into 3 plus 37 into 1 divided by the whole number. If they are giving it in percentage, divided by 100. If they are giving it in ratios, just add those ratios. Take 3 plus 1, that is 4. So which will comes out to be 35.5. So that is the average atomic mass of chlorine. That's what we are using. So here is your homework. Find the molar mass of the following molecules. So given that potassium, sulfur, iron, carbon, nitrogen, oxygen and hydrogen, just find out the molecular mass of these 5 compounds. The first one, let me do it for you. Ozone, O3. So 3 into oxygen, atomic mass is 16. 3 into 16, which will be 48. Okay, so 48 is the molar mass of ozone. Similarly, you can do it for the remaining. Here comes the interesting part. Mole, right? So scientists have discovered or did the revolutionary concept which changed the chemistry forever. 1 mole of a substance is defined as the number of entities. It's just an entity. That entity can be of apple, entity can be of your dresses, entity can be of stars, moon, sun, anything. Okay, same as the atoms present in 12 gram of carbon-12 isotope. So that is equal to our Avogadro number. That is nothing but 6.023 into 10 to the power 23. Imagine how huge the number is. Can you imagine how many zeros I have to put to imagine that number? It is a counting unit for this microscopic world. Let's see the relationship. This is a very important chart. You need to take a screenshot of it and save it or note it down in your notebook and stick it in your room. Okay? Or just note it down, which is very important. Number of particles, for calculating number of particles, moles into Avogadro number. Na is Avogadro's number, right? Then number of moles equal to number of particles into Na. Okay, so particles, moles by Na, moles, particles divided by Na. Mole to mass conversion, mass to find out mass, moles into molar mass. Moles just ulta, mass by molar mass. Mostly we will be using this particular formula for the conversion. If you know one, another one will be easy to do, right? Just remember the first one or the second one. The other thing you can easily calculate by shifting it. The third relationship is mole to volume conversion in case of gases. Okay, in case of gases, you need not to calculate any molar mass. It is not needed. Whatever the gas it may be, oxygen, carbon dioxide, carbon monoxide, nitrogen, ozone, whatever the gas it may be, you need not to find any molar mass or molecular mass. Just you need to know what condition that gas is, whether that is an STP or some other condition. For STP condition, that is standard temperature pressure, so which is 0 degrees Celsius and 1 atm pressure. In that condition, you can easily find out volume by multiplying moles into 22.4. For the given mole, just multiply into 22.4, you will get the volume. Okay? Ma'am, what if they didn't mention that is STP condition? What if they are giving some other temperature and pressure? Then you have to use the ideal gas equation PV is equal to nRT to find out number of moles. Or if they are given the number of moles, you can find the volume. Okay, for non-STP condition. Okay, moving on to the problem solving part. How many atoms are in 0.5 moles of iron? So iron is a solid. So what is the molar mass of iron? Which is equal to 56. How many atoms are there in moles? So we already know, the particle, number of particles is moles into Na. So we need not to have the iron molecular mass as well. So number of atoms equal to moles into Na, which is 0.5 into 6 into 10 to the power 23. That becomes 3.023 into 10 to the power 23 atoms of iron. Okay, as simple as that. Let's do one more problem. How many moles are there in 1.8 into 10 to the power 24 molecules of water? They have given the molecules, asking for moles. Just compare it with the chart. Given the particles, asking for moles. So we have to divide it, right? So just number of moles, which is equal to molecules, number of molecules divided by Na. So which is 1.8 into 10 to the power 24, 6.023 into 10 to the power 23. So which will comes out to be 2.99, approximately 3 moles. Okay, that's why I told you that chart is very, very important. Let's do this one. What is the mass of 0.25 moles of calcium carbonate? They are asking for mass. So we need to know about the molecular mass. So first, let's calculate the molar mass of calcium carbonate. Calcium, which is 40, carbon 12, oxygen 60. That is the atomic mass of these particles. So 1 calcium is there, 40 into 1 plus 1 carbon plus 3 oxygens, 3 into 16, which will comes out to be 100 gram per mole. They have given 0.25 moles. So mass equal to molar mass into moles. Moles into molar mass, which is 0.25 into 100, which will comes out to be 25 grams. Okay, clear? Moving on to this chart. This is the overall chart which explains how to convert one to another. You can also take a screenshot of this. Grams to particles conversion, particles to moles, moles to mass. This entire triangle is given over here. Let's solve these type of problems which is having the volume connection. How many molecules are in 5.6 liters of carbon dioxide? So they are asking for molecules in carbon dioxide. So carbon at STP condition. Okay. So what we said already, number of molecules which is equal to number of molecules which is equal to moles into Na, right? So for that we have to know about moles. So moles, number of moles, which is 6 divided by STP condition, no? So 22.4, which will comes out to be 0.25 moles. So moles into Na, 0.25 into Avogadro number, that is 0.25 into 6 into 10 to the power 23, that will comes out to be 1.506 into 10 to the power 23. That you can easily solve. Then example 2, what volume will 9.033 into 10 to the power 23 atoms of helium occupy at STP? They are asking about volume. Then again we have, in the first question they have given the volume and asking for the molecules. In this question they have given the particle and asking for the volume. Just ulta. So what we have to do, find the moles, which is 9.033 into 10 to the power 23 divided by 6.023 into 10 to the power 23, that is 1.5 moles. And for volume, which will be mole into 22.4, that is 33.6 liters. Either the way the question can be asked. Let's see one more example which is asking for the both. The mixture contains 0.2 moles of N2 and 0.3 moles of O2. Find the total volume of STP, number of molecules of each gas. This is a mixture. So what we have to do? Let's find out the total moles. Total moles, which is equal to 0.2 mole plus 0.3 mole, that comes out to be 0.5 mole. Right? From that, total volume. Total volume will be 0.5 into 22.4, that is 11.2 liters. Ma'am, they gave the different gases. But I already told you that in case of gases, you need not to worry about those things because of Avogadro's law. Just go back and check what Avogadro's law states. Okay, fine. We found the total volume. Option, the part A is sorted. Then part B, number of molecules of each gas. So number of molecules of nitrogen, let's find out. So N2 molecules, which is 0.2, right? 0.2 into Na, that will comes out to be 1.204 into 10 to the power 23, and O2 molecules, that is 0.3 mole, that will comes out to be 1.807 into 10 to the power 23 molecules present in 0.2 and 3 moles. Okay, cool. In case of, if they are giving us a mixture also, you should be able to do it. To the next concept, that is gram atomic mass, gram molecular mass and gram ionic mass. These terms can be confusing, but it is not. Right? So just understand this term. Gram atomic mass is just like a mass of 1 mole of atom of a type in grams. And gram molecular mass is mass of 1 molecules of type in grams. We are just taking it in grams. Atomic mass in grams, molecular mass in grams, and ionic mass in grams. Okay. Here you have the example, 1 gram atomic mass of hydrogen, which is equal to 1 gram of hydrogen. That is 6.022 into 10 to the power 23 atoms. That is nothing but 1 mole of atom. Right? Similarly, 1 gram atomic mass of oxygen, that is 16 grams of oxygen, which is 1 mole of oxygen atoms. The same thing applies for every other element in the periodic table. Similarly, gram molecular mass, let's take H2O, water. The molecular weight is 18. Gram molecular mass is 18 grams, which is 6.022 into 10 to the power 23 molecules, which means 1 mole of molecules. 1 mole molecules. Okay, so once again I am telling you, mole is just a unit. It's not a unit, it's a quantity to measure. It applies everywhere. Similarly, gram atoms, gram molecules and gram ions. Then, second most important part, percentage composition formula. This type of questions you can expect in board exams as well. First, let's understand what is percentage composition. How much percentage is present in the total compound? Okay, so let's take this formula of mass of the element in compound divided by mass of molecular mass or total molar mass of the compound into 100, because they have mentioned it as a percentage. That's why we are making 100. Okay, let's see an example. Find the percentage composition of aluminium sulfate. Okay, let's find it out one by one. Aluminium sulfate. What is the molar mass? Molar mass of aluminium. For aluminium, that is 27, sulfur 32, oxygen 16. So 2 aluminium, how many sulfur? 3 sulfur. How many oxygen? 4 into 3, 12 oxygen. 4 into 3, 12 oxygen. 12 into 16, which will comes out to be 342 gram per mole. That is the molar mass of aluminium sulfate. Now we are going to calculate the percentage composition. Percentage of aluminium, which is the total part of aluminium over here. That is 2 into 27, 54. So 54, I am writing it clearly, 2 into 27 divided by the total molar mass 342. So the percentage is coming out to be 15.79 percentage. 15.79 percentage of aluminium is present. Similarly, let's calculate it for sulfur. So 3 sulfur is there, 3 into 32 divided by 342, which is 28.07 percentage of sulfur is there. And percentage of oxygen, that would be 12 into 16 divided by 342 into 100, that comes out to be 56.14 percentage. So here is the tip. In your examination, how to check whether you have calculated right or not. Overall, we are calculating it as a percentage. So by adding all three, you should get 100. Okay, that thing you have to remember whenever you are writing this type of question. Okay. The second type of question can be asked from this part is, a compound contains 26.57 percentage of potassium, 35.36 percentage of chromium and 38.07 percentage of oxygen. Find the empirical formula. What is empirical formula? So, empirical formula is the simple whole number ratio. I would always say empirical formula is like a nickname. Okay, it is more generic. Let's say your name is Nandini. Okay, some people call you as Nandi. Similarly, if some other girl is having a name Nadia, their friend will call them as Nandi. Right? It's a more generic name. It's like your nickname. But in case of molecular formula, it is the actual number of atoms present over there. It is your full name with initial like that. Okay, with your surname like that. It's more specific than the empirical formula. So that is the relation, that is the definition of empirical and molecular formula. So what is the relationship between these two? Is multiplying by one factor, whole number factor. Let's say that whole number factor is n. Multiplying by the number n, you will get molecular formula. Multiplying the empirical formula with the number n is the whole number, you will get the molecular formula. We will see the examples, don't worry. And how will you calculate n? N is equal to molar mass divided by empirical formula mass. Okay. Let's take the example of C2H6, right, which is CH3, C2H6. I can write this as CH3. So this is my molecular formula and this is my empirical formula. And the factor here is n is 2. By multiplying CH3 into 2, I will get C2H6. Are you clear? Let's solve the problem. here we have the percentage composition and asking for empirical formula. So percentage of potassium is 26.57. So let's take potassium. 26.57 percentage is there. I already told you percentage is for 100, right? So I'm going to assume that the whole compound is 100 grams. From that, 26.57 gram is our potassium, divided by the molar atomic mass of potassium, that is 39. So which is giving you how many moles, right? The step 1 to find number of moles. So find the number of moles over here, that is 0.679 mole. Then next one is chromium, that is 35.36. The atomic mass of chromium is 52. So the mole will be 0.680 moles. Then oxygen, 38.07 divided by 60, which will come out to be 2.379 moles. Okay, so these are in the ratio of 0.6, 0.6 and 2.3. As the next step, what you have to do is, you have to make it as a whole number. For that, I am going to take the smallest number out of these three and divide it by them. Divide by smallest number. Okay, out of here, which is smallest one? That is 0.679, right? So both are small only. You can take either of the way. So 0.679 divided by 0.679, which is equal to 1. 0.680 divided by 0.679, which will be approximately 1. And finally, I'm having 2.3. 2.379 divided by 0.679, which will be approximately 3.5. So which is in 1:1:3.5 ratio. I'm going to make it as a whole number, because empirical formula is the whole number. So which will comes out to be 2:2:7. So what is the formula? K2Cr2O7. Okay, clear? Let's solve one more problem. This is water of crystallization problem. Ma'am, what is water of crystallization? So in a compound, in a salt, there will be some amount of water in it. By heating it, it will go away. Okay, but as it is a salt form, it would absorb some amount of water. That will gives them the color. So those and all we will discuss it in inorganic part. Now we are going to find the X in this molecular formula. Copper sulfate XH2O loses 0.90 grams of water on heating. Find X. So overall mass is 2.5. So how much this is losing? So after water is lost, it becomes anhydrous, right? So anhydrous copper sulfate mass, that is 2.50 minus 0.990, right? That will comes out to be 1.6 grams. So what is the molar mass of copper sulfate? So I'm doing it here. Copper, which is 63, and sulfur, I think 63.5, and sulfur 32, oxygen 16. So overall the molar mass of copper sulfate is 159.6 gram per mole. So what is the moles? For calculating mole, they have to use 1.60 divided by the molar mass 159.6, that is 0.01 mole. Okay, so similarly we are going to calculate it for water. We know the molecular mass, that is 18. So moles of water, which will be, the last amount is 0.90. So 0.90 divided by 80, which will be 0.05 moles, which is in the ratio of 1:5. How will you calculate the ratio? Dividing it by the smallest number, right? 1:5 ratio. So copper sulfate and 5 is H2O. So X value is 5. Okay, clear? You can take this problem as your homework. 0.200 grams of hydrocarbon produces 0.6006 grams of carbon dioxide and 0.2459 grams of H2O. Vapor density is 39. And what is vapor density? We don't know about vapor density. Vapor density is nothing but the density of vapors. But here is the trick. Whenever they are giving you the vapor density, you can easily calculate the molecular mass from it. Okay. So molecular mass, which is equal to vapor density into 2. Okay. So vapor density into 2, that is your molecular mass. From using this, you can find the molecular formula. So I request you to solve this problem. After finding molecular mass, you just have to find the molecular formula. That is your question. Just solve it. If you not able to solve it, just mention it in the comment. Need answer. Okay. We'll solve this question in the next session. Or else, if you able to solve it, I'm giving you applause from here and mention the answer in the comment box. Okay. So stay tuned. We are going to post more and more videos. We are going to cover entire 11th grade.